In this session, we're going to talk a bit of architecture and patterns and how we can how Microsoft Fabric will be able to deliver a federated data landscape. So let's get started. So quickly about me, my name is Andreas Bergstedt. I work for Microsoft. I belong to the data and analytics global black belt team. I've got roughly about 30 years in the IT sector, and the last 20 years of those are within the data side. I've worked through many verticals and industries, and help deliver across a broad spectrum of both public and private sector bodies. Cool. Quick agenda check for this session. So we're going to start with the Microsoft Fabric overview. After that, we're going to go through some of the fundamental patterns and principles that we need to keep in mind to operate within Microsoft Fabric effectively. And then we're going to talk a little bit about the data architecture that's associated with Microsoft Fabric and how we can deliver that, and then how that supports federated analytics. Cool. So Microsoft Fabric, when Microsoft started its or came up with its vision for its next analytical platform, we wanted to build a complete and analytics platform. We wanted to make it lake-centric and open. We wanted to empower every business user, and we wanted to infuse AI wherever we could. Everything should just be AI powered. So if we dig into these four objectives or principles, then we see the following. So complete analytics platform. So we want everything to be just integrated by default. Everything should just be unified on one canvas. It should be a SaaS operated product with personas, so that you get, depending on your skill set or your role, you would have always the appropriate tools available to you. And the second thing, or the third last thing we want to do was also everything should just be secured and governed at tenant level, right? So you should be able to create your reports or your experiments or your whatever you're generating in this analytics landscape with the trust that everything falls within your guidelines. You're not exposing the business to risk by sharing things the wrong way. Everything is always governed, so you don't have to worry about you breaching any policies. The second principle, lake-centric and open. So this is to what gave birth to One Lake. So a central managed data lake for your own for your entire organization. We work with polyglot store principles. All of that is great. We have a central way of accessing data, and then our one copy principles, where you're able to reuse or shortcut data without having to duplicate it. So you don't have to you don't have to regenerate or reprocess, reload data. It should just, if it's already been processed, curated, you should just be able to consume it and use it in your process and building your data products. And then open at every tier. We don't want to lock anyone down. You should be able to come in with external tooling if you want to, and and process your data or grab the data that you've been working with. The third principle is to empower every business user, and that's just familiar and intuitive, right? So we want to see Microsoft Fabric as the office of data, right? And this is, we want to be able to build in capabilities and integrate with Microsoft 365 where we could, be that in Teams or in Office or whatever. It doesn't matter, right? And then we want this to be able to help every business user to drive insight to action. The last pillar is around the AI powered. So we want to be able to have co-pilot acceleration everywhere. So to help, let's say you are you're starting out with as a data scientist, or you're venturing into data science and you want to build your first regression model. There should be a co-pilot available for you to ask those questions and help you build a pattern. Or let's say you're a citizen developer and you need some assistance with your data flow curation. So how does Dataflow Gen 2 operate? So, show me how to build this Dataflow kind of thing. So that was the Copilot acceleration. And then we want to be able to do the Chat GPT or the OpenAI, um, you know, in, interactive data bot thing. So you should be able to ask questions out of your data and get really good answers back without having to trawl through massive amounts of data for research. And then everything should just, um, we just want to help you drive these AI driven insights where all of a sudden you can see everything without having to have gone through everything with the assistance of our AI investment. Cool. So Microsoft Fabric, it is then in a nutshell 7 workloads or serverless compute workloads. There are a few other derivatives underneath some of these layers, but in principle, you've got 7 different type of workloads, and we refer these to as personas as well. So data factory, so this is our data integration workload, how you do data acquisition, that sort of thing. You got Synapse Data Engineering, which is our Spark workload, where you can build scalable patterns or data engineering patterns. Then we have Synapse Data Science. So this is our ML Flow integrated, Synapse ML integrated data science workload with our Spark clusters. And then we got Synapse Data Warehousing. So this is our traditional take. You can't see the air quotes, but quote traditional, right? Data warehousing workload. It's still 100% serverless and segregated. Data and storage is completely segregated or separated. Then we got a real-time analytics workload. So we have our Custo database engine, our time series database engine, right? As well as our event stream capabilities for you to do real-time transformations and analytics and push them down to, for instance, Power BI. And then we have Power BI with its new features and functionalities such as our Lake Direct capability, so you don't have to read data from a SQL endpoint. You can read it as it lies in the lake. And then the final one, which is Data Activator, which is our insights to action framework that allows you to build, real-time operational flows that can, prompt teams to react to things such as, either fraud detection use cases or, things like unhealthy actions in your data or, um, you know, get a driver off a shift because he's been driving for too long, those kind of things. But truly that bridge between, systems of information and systems of action. And then all of this is part of the Intelligent Data Foundation that is rooted in OneLake. So our managed data lake. And that then has different layers to it. So we have our one security principles around, one way of accessing data. So you have one authentication method in everything, and all security policies and everything operates throughout this realm. We have our universal compute capacities, our shared workspaces that enables you to have interactive and collaborative experiences with other users and domains in your organization, as well as then the AI assisted layers on top of this. That's Microsoft Fabric in a nutshell. So let's look at some of the underlying principles and patterns that are very close to Microsoft Fabric. So the first one I'm going to talk about is the data lakehouse pattern. So we have, if we look at the end-to-end flow Microsoft Fabric, it's been built for the data lakehouse pattern. So when we think of some of the most fundamental patterns in modern analytics, the one that stands out is then the data lakehouse pattern. It's been building over the last couple of years, and this pattern is rooted in the data lake architecture, but it has a very specific characteristic or differentiation, and that is that it's sort of derived by to create a set of standard zones that describe the data curation process and ensures that we have a high level of trust in our data. So, in other words, we go from low bronze, yeah, our raw, to gold, our business refined and trusted data. So there's like a level of trust in this pattern, right? Three layered zones really, should be really easy to understand. Now, it's important also to understand that this is just, you know, that the data lakehouse pattern is just a set of principles. They can be bent and adapted to make more business and operational sense. So, for instance, we might have a central IT domain that delivers a set of operational data stores. Now, these are delivered into the gold zone, right? Where they are consolidated with operational level contracts and guarantees. Now, these will serve as a curated and trusted data source for another business domain, for instance, as their bronze layer. Or they might see it as, this is how they do bronze layer acquisition. And as a transactional, data source in another gold layer, perhaps. Now, um, it's important that we think about this because many organizations might say, "Hey, I have, I have my load stage, integrate, and model layers in my data warehousing patterns. So what do I do with stage, or what do I do with integrate? And you should be able to adapt it here if you break down the processes. And it's interesting that it's important that we think about this. If you come to a part where you have an SLA or guaranteed product, that should always be your gold layer. So the another consideration is that the mapping of zones to existing data layers, for instance, if we map the traditional data loading zones of stage, and this is now getting to some of the details here, or stage, integration, and mod, we can easily treat then stage as bronze or raw, right? So we stage data into our raw layer, and integration is silver or conformed layer, silver or conformed, right? And our March layer is, or your final dimensional layer is then in your gold or model layers, right? So, in short, the principles are designed to be flexible and act as a set of guidelines on how data should be handled and consumed. That's it. There is nothing, these are not, it's not an architecture, and that's another thing that often gets misconstrued. It's a pattern, it's a set of principles. Cool. The next part I want to talk about is data products in terms of patterns and principles. Now, fundamentally, when we think about data products in the enterprise data flow, um, and in the context of Microsoft Fabric, it is important that we abide by the sort of three fundamental principles. Now, in no particular order, they are equally important, all of these. Data products must have an associated service level agreement or operational level agreement. This is important because as soon as a data product is considered a product, it is then, this is a product or a service. And then we go back to the whole thing around ITIL service delivery mechanics. If it's not a product or a service and it doesn't have an SLA associated with it, it has no product, it has no value, it shouldn't be there. The data products must have an SLA or OLA. if it's internal. Data products can be derived from other data products. So think about the scenario with a central IT building up an ERP ODS. So that ERP ODS can then serve, the finance domains serve as a data source um, for the finance domains data models, right, and their data products, right. And then the third principle is that data products must be published out of the gold zone. Now, I cannot stress this enough. This is if we want to have if we want to treat gold, or at least see that gold zone as our trust highest level of trust on our data, then that's obviously where data products must come from. So anytime you build a data product, it must be there, because you then have an owner. It's SLA'd. You understand its consumption. You understand its origin. You understand the data process is well documented. At that point, that's where the data products must be published out of. Um, so at this point, this is how we can stay true to Microsoft fundamentals, principles such as Microsoft Fabric's fundamental principles of one copy. Now, there are all of these are extracted. These three principles are extracted out of the well-architected framework, or our cloud scale analytics well-architected framework. They are, they're universal principles, and if you stick to them, your Microsoft Fabric deployment you'll be able to build out federated environments with Microsoft Fabric. So if we quickly now go to the data architecture of things, so let's look at some of the reference architectures. So here is the Synapse Analytics reference architecture diagram. Well, this was the latest one we published, where we have our, a cold path and hot path, typical Lambda style pattern. And then we represent our storage layer as raw, cleansed, or curated, or bronze, silver, and gold. And we then have different compute engines to process this. All right, now, and also we can see here we've got machine learning services, etc., different ways of running model training and scoring, etc. Now, if we look at that from the Fabric lens, this is how that translates. So here we got the same kind of patterns. We have batch and streaming ingestion capabilities from our data factory workload, and our event streaming capabilities, and also Spark streaming if you need to. We can then we land data in a bronze zone. We can then forward process using real-time analytics to publish forward, or curate forward, right? And then we can use Spark workloads or DML language to build up data warehouses or lakehouse SQL endpoint or lakehouses. And then obviously at the gold layer, we also have the ability to work with our model scoring. We also have the ability to build out in fusion with our ML Studio or AI Studio, to then further augment this data and enrich it. And then we can then serve this out either as apps using APIs, or Power Apps or something like that. We provide ad hoc SQL analytics or SQL endpoints, as well as then Power BI for future serving. Now, this is as we see the sort of the full end-to-end Microsoft Fabric pattern or architecture, but we also have another valid architecture. So we've got the Microsoft Data Warehouse pattern. So, for instance, if you are a traditionalist organization and you coming from an on-prem environment to onboard this sort of full lakehouse pattern might be a bit daunting. So we support obviously our modern analytics or modern data warehouse pattern in Fabric. And this also enables us to stay true to the one copy motion. So you have the ability to run batch ingestion, and you stage this into one lake. And this is the same way you would stage in your raw zone or your bronze zone. The same principles for stage. We can then use DML code to lift this data into staging tables and then forward process it into our data models and data warehouses using traditional store procedure and DML processes. And then from a publishing perspective, we can build data products then using the lakehouse endpoints, shortcutting to our main data warehouse and just adding that additional business augmentation or the business language on top of the data warehouse, so to speak. And then from here, it's the same way. We serve using our SQL endpoints and Power BI. We also can, at this point, and this is not obvious, but we can also add this AI layer or augmentation layer on top of the data mods or the lakehouse endpoints to further enrich our data and use it, in terms of business chat, etc. Cool. So now, if we think about these two patterns, so we think about these two architectures, so we think about this, we think about this, it is now easy to see because everything is stored in one lake and everything is stored, all data, all compute endpoint stores everything as delta tables in the back. It's easy to see this in a federated analytics pattern. So, for instance, if we have this scenario where you got two domains, you got finance and marketing. Now, we already discussed this central IT domain that was processing our ERP data. So, because they have stored this in one lake, finance can just consume this data either using the data engineering or their data warehouse or lakehouse endpoints and just shortcut to the data, forward process it, augment it, and then produce their their finance dashboard. So they might, out of the ERP data sets, you might have daily revenue data, you might have you've got your general ledger, you've got your P&L, all of that, and they've built data products on top of this to summarize this and build industrialized finance reporting. And marketing to the same point, they might see, what is my product product processing. They might have their own external marketing sets. They might have data they've processed from clickstream data from the website, and then they correlate that with order flow, with stock levels, those kind of things, and they're able to produce marketing dashboards and information that is viable or valid as well, or valid for marketing, and that serves business value. And if we think about this on a bigger scale as well, we can even see, since one lake is an open platform, we can even have, multi-cloud awareness around one lake. So we can have shortcuts to S3 buckets for some domains that have been maybe have pushed or processed data in, using Databricks in AWS or elsewhere, or external data that's been acquired from other organizations or acquisitions. And everyone can operate with their own compute patterns. So if one domain likes to use Azure Databricks, they can use Azure Databricks. If we got external or domains that are using Snowflake on Azure, then We can replicate or mount that data in a warehouse endpoint inside of inside of OneLake, so that you can democratize your data investment no matter where it sits. And this is truly, truly a game changer when it comes to federated analytics, specifically related to Microsoft Fabric.